Welcome to the Geo Show. Today's video is about water on Mars. How do we know there was water on Mars? How much water was there? And where did all the water go? The earliest evidence for water on Mars came from the Mariner 9 probe. The images that it sent home showed these huge channels that clearly have features that are associated with the flow of fluids, like these teardrop-shaped bars that are deposited there by moving water. Now, obviously, this happened during the early 1970s, and the resolution was nowhere near as good as these beautiful high-rise images, which are from a much later, more advanced satellite. Further evidence was found by the early rovers who detected clay minerals. Every geologist knows, or I guess every geologist should know, that clay is produced by hydrolysis of various minerals. Now, hydrolysis is a chemical reaction that only occurs underwater. Additional geological proof came a little bit later with more advanced rovers who detected these types of structures, which are ripple structures. They form when water moves across it, so they are associated with moving water. So the high-rise orbiter that I briefly mentioned earlier stands for High Resolution Imaging Science Experiment. And this was launched in 2006 and was a real revolution. And in fact, most of the images that you're looking at right now, these very beautiful high-resolution images, are from the high-rise orbiter. And when this orbiter was active, it sent home some really beautiful images of further evidence that a large amount of water had flown on the surface of Mars. So for example, this is another very beautiful channel, a very big one. So in this case, it's more than 7 kilometers wide. So this is evidence that a huge amount of water had flowed on the surface of Mars. Now clearly, these impact structures had occurred after the formation of this channel because it sits directly on top of it. So that shows you that a lot of time has passed since these channels formed. Perhaps the most famous and dramatic evidence for significant amounts, so large amounts of water on Mars, is this feature, which is known as the Eberswalde Delta. Deltas are areas where a lot of sediment is deposited, and they form when a river, so in this case this feature here is interpreted as a river, when the river hits a standing body of water, the sediment that's carried by the river is deposited, and that forms a huge fan shape. So here's another lesser known water feature that is large on the surface of Mars. It's called the Apollinaris fan. This sort of feature does form in an environment where frequently sheets of water move downward and build this structure. So if we know for a fact that liquid water has existed on the surface of Mars, then I guess you could ask the question, where did all this water go? And a lot of you will say, well, it's simple, Mars is just too cold. And yes, we do have these polar ice caps that contain a lot of frozen water. So there's a lot of ice on the surface of Mars. But the problem is actually not related to temperature. So what we see here is called a phase diagram, and it shows you the pressure and temperature regime in which water is solid, so ice, liquid, so liquid water, or vapor. And it's a function of not just the temperature, but also the pressure. So the pressure here is on the y-axis. And you see that the highest temperature on Mars is actually not that cold. So most of Mars is very cold, 100 Celsius below freezing. But the highest temperatures on the surface of Mars are actually significantly above freezing. So let's say 15, even 20 or 25 Celsius. The problem in this case is that the pressure on Mars is very low. So it's below this point, which is called the triple point, which is the exact point where liquid, solid, and gas sort of exist in the same environment. And because the Martian atmosphere is consistently below the triple point, it doesn't matter the temperature. The water will never be liquid, right? So it's going to go straight from solid to vapor, or the other way around, straight from vapor to solid, skipping the liquid phase. So that means if we want to discover why the water disappeared, we shouldn't look at the climate necessarily. We shouldn't necessarily look at the temperature, but we have to consider the pressure, which at this moment in time is only 1% of the Earth pressure. And there are various reasons as to why this pressure went down. So the first factor I'm alluding to by looking at this huge mountain, the biggest mountain in the solar system, Olympus Mons, which is a giant volcano. And there are actually various volcanoes on the Martian surface, none of which are active. So one of the reasons why the pressure declined is because the volcanoes that used to add gas to the atmosphere, they all stopped working. So they all died out. What most scientists believe is that Mars has simply died by freezing. So what makes planets hot on the interior is its formation. So planets are formed by small rocks, small planetesimals, so small pieces of asteroid and stuff that coalesced into a bigger planet due to gravity. And this coalescence obviously had a lot of impact and friction, which generated a lot of heat. Now, over time, this heat will very slowly decline. And because Earth is such a big planet, it hasn't really significantly cooled down the interior of the Earth in the past 4 billion years since its formation. So this cooling of the planet has had two effects. So one is it caused the volcanism to decrease in activity. And two, it has caused the outer core, the liquid outer core, to freeze with respect to the solid inner core. So the entire core of Mars is now believed to be solid. Now, why is this important? This is important because the interaction between the liquid outer core and the solid inner core is what generates a magnetic field. And a magnetic field is instrumental to deflecting solar radiation. Now, when I'm talking about radiation in this case, I'm not talking about light, but I'm talking about particles of solar matter that are hitting the Martian atmosphere at very high velocity. So the sun actually emits an enormous amount, an enormous mass of material into the planetary atmosphere. Now on Earth, a lot of this material is deflected by the magnetic field, but on Mars, all this material is impacted into the atmosphere because the magnetic field is almost entirely gone. And that has caused erosion of the atmosphere over time, which has caused the atmospheric pressure to go down, which has caused all the water, all the liquid water, to essentially evaporate. Now, based on observations by the Mars rovers, scientists have been able to put together a geological history of the planet. And it looks a little bit like this. In the very early Mars, it was probably very hot and there was a lot of impact, so there was not that much water. But then shortly thereafter, so we're talking about 3.3 to 3.7 billion years ago, we get these episodes of a lot of liquid water. And probably towards the end of what they call the Hesperian period, which is 3.3 billion years ago, Mars had its peak amount of water, oceans and seas, and actually very, very large water bodies covering a significant portion of the Martian surface. So the picture that you see in the thumbnail of this video of Mars covered in oceans is actually not that unrealistic on how it looked like 3 billion years ago. Now, after this period that they call the Amazonian, the volcanism declines and the atmosphere becomes so eroded, so deteriorated, that the Martian pressure goes below this triple point. And from then on, there really is no more liquid water on Mars. So one of the biggest mysteries is how long did these episodes of liquid water persist? So some people think that there have been oceans for perhaps millions of years. Some people think maybe these were very short-lived, so maybe only after an impact which temporarily increased the temperature or after a massive increase in volcanic activity. So there's a lot of uncertainty on how long these episodes of liquid water existed and perhaps whether that was long enough to generate life. So I hope you enjoyed this episode on water on Mars. Don't forget to like and subscribe to our videos.